Hello and welcome. My name is Jim, and recently while doing a glue up, I was wondering how strong the joint is and how much clamping pressure do I need to put on it to make the strongest joint. Do these little spring counts put out enough clamping pressure? Do I need to put any clamps on it at all? If I put one of these clamps on and really crank it down, will I squeeze all the glue out of the joint? I was wondering that, and then I started thinking, which type of glue should I be using? Is this one going to be any stronger than this one? And then I was thinking, well, do I need to sand the joints before putting everything together to roughen them up and give the glue something to bite on? There's lots of information online about how to do a glue up, and everybody has their own opinion about how to make the strongest joint. But I wanted to do some actual testing to figure it out. So I'm going to build a test rig to test glue joints. And I was looking around to see what the best way to do that was. And fortunately, the American Society of Testing Materials have already come up with the best way. And they've wrote a paper on it, the ASTM D905 document. And that details how to build a tester. So it tests little blocks of wood like this. It's a 2-inch by 2-inch block with glue in between. It puts pressure on top, on this side here and this side here, and it'll shear that joint apart. And so then you can test lots of different variables and see what makes the strongest joint. So that tester from their document looks like this. I'm going to build my own version out of wood. So I've drawn that up in CAD, and that looks like this. So that's what we're going to do today on
Kilimanjaro.
I'm going to start by working on the anvil here. So this block of aluminum is going to become two pieces with an arc in between them that will allow it to rotate and apply the force evenly onto the test part. So I'm just going to mark that on the part, and then I'll take it over to the bandsaw here and cut it out into the two separate pieces. This is just a little portaband I've got here set up on a little stand, and I'm just pushing it through with a block of wood on the back in case it jumps, that it's not going to hit my fingers. With my stock all prepared, I'm going to go over to the mill. I want to set up my rotary table on the mill, but it's pretty heavy. It's a 12-inch rotary table. It weighs over 100 pounds, so I'm going to use a little chain hoist here to lift it up and then slide the milling table underneath it, and that way I can easily get it on there without having to worry about breaking my back. I've got the part clamped down to the rotary table here. I start making the cut, but I realize that the chips are starting to weld to the end mill. So I set up my cool mist with a little bit of kerosene here, and now you can see it's making real nice chips, and it's cutting real nicely. So I'm just going to work my way back and forth on this block here, making the cuts deeper and deeper until I get up to about my line, and then I'll check my dimensions here to see if I'm at the right dimension. Once I'm happy with the arc cut in there, it's at the dimension that I want, I'm going to switch over from my end mill to what's called a keyhole bit. This bit actually comes from a router set that I have. It's not even a particularly nice router set. It's meant for wood. It's a big Craftsman set, and it's only got a single cutter on the edge of it. But as long as I take it slow, it seems to work reasonably well in aluminum. I'm sure I could get a better finish if I used a nicer bit. This is the one I have, and so I'm going to go with it. That groove that I'm going to end up cutting in here is meant to keep the two pieces aligned, and so they don't slip out while I'm trying to use the shear tester to break the parts. So I'm going along making a nice shallow cut here when I realize that the bottom of the spindle is hitting my clamp, so I'm going to have to move that clamp out. This bit is not particularly long, and it's only a 1/4-inch bit, so I don't want it to stick out any more than actually really necessary. So I'll move the clamp back here and then try again. You can see with some coolant on there, it cuts pretty well. So I'm going to go through here, make a couple passes until I get the groove up to the depth that I'm happy with. Once that's done, I'm going to switch over to the other piece. This is going to be the piece that goes into that arc. So the way I've got it set up, I've cut a piece on the lathe that's the right diameter so that I can just push this right up against that, and that'll get it all nicely aligned to have the arc in the right spot. I'm going to clamp down the first side on this part, and then I'll pull the spindle back up and use another clamp to actually clamp down the arc. So I'll have both pieces clamped down while I'm cutting it, and it should be nice and secure. Making real care here to make sure that my parallels on the bottom aren't under the path where the bit's going to be cutting, because I don't want to cut into those parallels. Once I've got it all clamped down, I'm going to switch the end mill out to a 1/4 inch end mill here. I find a 1/4 inch works pretty well because I'm going to be making a slot here. I don't want to plow a 1/2 inch end mill and remove a whole ton of material. And it's wide enough still that it's still pretty rigid, and with the air blast on it, it'll blow the chips out of the groove nicely. Once I finish milling that slot, I'll take off the other piece and then switch over to my keyhole bit to remove the material on the bottom here. So this will leave a nice little protuberance that'll ride in the groove I made in the other part, and that'll slide real nice after I put a little grease on it, keep these parts aligned while I'm loading up this jig. Once I'm done making that cut, I'll switch over to my little die grinder here, and use that to remove all the burrs that are on the part. I find this die grinder with a little Scotch-Brite wheel on it works really well to get in there and deburr the parts, puts a nice finish on the edge, and it's really quick and easy to use. So go check that fit, and that slides in there real nice. Easy to move, but it still is locked in there pretty nicely. So now once that's done, all I've got to do is finish squaring up the bigger block there. The edges are still rough cut from the bandsaw, so I'm going to take my rotary table back off the mill, same way that I put it on by just clamping a piece of bar over my lifting strap, move the table out of the way, and then you use my chain hoist to lower it down. I keep the rotary table on a dolly next to the mill. That way I can if I ever need to, I can move it away, roll it around, but most of the time it's just nice and out of the way. It does get some chips on it from time to time, so I do have to clean it off, particularly before I'm going to use it, but it's a nice, easy way to keep it out of the way and not hurt my back when I'm trying to lift it out. Once that's off, I've got to put the vise back on the table, but first I got to clean it off, so I'm going to get the vacuum out, suck up all those chips everywhere from the ways, from the rest of the machine, and then wipe it down, and then I'll put the vise on. So the vise doesn't weigh nearly as much, so it's a lot easier to just put on there, lift it up. I'm going to use some bolts to clamp it down and hold it in place. Now, this is where things start to go badly. I want to indicate in the back of the vise, so I'm going to switch over here to a little indicator in the mill, and then I don't realize that one of the wires from the power feed is now caught over the back of one of the handles on the mill. I moved it out of the way when I was lowering the rotary table. So you'll see here, I start moving the table forward after I've got the indicator in position, right about here, and you'll see there's a big spark from the back of the machine, right about there. So you notice I jump a little bit, and then I'm looking a bit. So let's see that again. So you can see, right there is a big splash. This is what ended up breaking there. So these are two little plungers that mount on the back of the table. They go with the power feed, and if they hit the end stop, it'll cut the power to the power feed. Now this is a pretty old power feed, and so this runs off 120 volts. So you can see right there's the wire missing. I ended up pulling that wire out and it broke, and that's what made that loud spark. So I had to go back and rewire that up. So it was a nice distraction while I was in the middle of my project here. Once that's done and I've got the vise all trammed in, I'll put this block in, use a little pin because the back of that block is not straight, it's just cut on the bandsaw, and then I'll go ahead and trim off the one side. I'm just back to using a nice 1/2 inch end mill here. Just going to make a couple passes to clean that up, get up to my line. The width of this is not a critical dimension, so I'm just kind of eyeballing it here until I get about a nice finish on the end, and I'm right up to my line that I scribed before. Then I'll go over and give that a quick deburr by hand. And put it back in to clean up that back face. Now both those faces that are on there are parallel, so I don't need to use a little rod there. You just clamp it down in the vise. Use a little hammer to make sure it's nicely seated. Then I'll go ahead and make a couple quick passes on this. Once again, I'm not real concerned about this dimension, it's not real critical, so I'm just going to make a couple passes until I get a nice smooth finish on there, and I'm about up to my line. So I'm going to go over and get my little handy burr out. and deburr all the little corners that I just worked on here, and then this part will be done. So after this, I've got to start working on the frame that'll hold this part. So for that, I'm just going to use some 2x4s. I'm going to take them over to the miter saw here and start cutting them to size here. So I'm going to leave them a little bit long. You can see on my markings there, I've got a couple marked out so they'll be together. And that way they'll stay a manageable size for running through the joiner and running through the table saw. So that's my next step here, is to run these through the joiner so that I get a nice clean edge on them. The 2x4s have a little bit of a round over on the edge, and the straight from the store they aren't real nice. So I'm going to clean that up on the joiner here. Once I've cleaned up each edge on the joiner there, I'll take them over to the table saw and cut them to width. This will also leave a nice good edge and make sure that they're all nice and parallel on both sides. You can see that some of these thin pieces are starting to get caught in the guard there. I have mixed feelings about the guard on this saw. Sometimes I feel like it's a good thing to have to keep my hands away from it, but other times I always am getting pieces stuck in it, and it actually, I think, makes it worse sometimes. So once those are cut to width, I'll take them back over to the joiner and plane off one of those faces there to make sure that I've got a nice good surface there. And then the next step is going to be to take them over to the planer. So my planer I usually keep tucked underneath my workbench here. It's on some slides and some hinges. This is really convenient. This planer is real heavy, and I don't really have a good place to keep it permanent in my shop, so I can just slide it out, although it does get caught on the vise right there. But then I slide it out, and then I've got a couple little legs that it stands on. So this way it's always out of the way when I don't need it, and it's easy to get to when I do need it without having to lift the whole thing up and maneuver it around all the time. The cord just goes to an outlet right on the top here, and then I can quickly run the boards through once I've got them hooked up to the dust collector. I was trying to run all the boards through at the same time, that way I wouldn't get any snipe on them. However, I managed to get one of the boards kind of stuck on the front of the planer there, so I ended up not being able to do that and did end up with a little bit of snipe, but it wasn't too bad. Once I've got these all planed, I'm going to take them over and cut them to a final length, and then I'll be ready to do some assembly. So I'm going to go over here and lay out some spots for some screws. I've got this set up using the holes in the MFT tabletop here, which are at a nice right angle. I've got a board clamped down to them, and then I've got a big block of aluminum on the other side that's up against some of the dogs going in the other direction, and that'll keep everything all nice and square. So I go through and I center punch all the holes here for the screws. That way I know that the screws are in exactly the right spot when I go to drill them. Now this drill bit is only going to go through the top screw, so it's not critical that it gets all the way down and that everything's all lined up when I do that screw. You can see that bit comes out there. I really hate the chuck on that Bosch 12-volt drill. It's really hard to get it clamped down real nicely, but eventually I do. Put some screws in there, have to go get a couple more screws, lay that all out, and screw everything together. So now I'm going to get a little fancy here, put a little round over on all the edges here. Just makes it a little nicer, makes it not so sharp when I'm maneuvering it around, and keeps the edges from getting as beat up. I'm just going to give this a quick sand, just to keep it looking a little nicer. And then I'll go ahead and cut a little piece of steel for the bottom here. Since this is going to have a lot of pressure on it, I didn't want the little test coupons to be sitting right against the bottom of that wood there. Then I'm going to go ahead and make a little plate for the bottom. I'm just going to cut a little hole here, not going all the way through, just a counterbore for the top of that jack that you can see right there. That way it doesn't slide around when I'm trying to jack that up to put the pressure on the test pieces. So I'll just screw that onto the bottom of this frame here. So next part I've got to make is a block to slide through that slot that's up there and then attach to the aluminum anvil that will actually put the pressure on the piece that I'm trying to test. So I'm going to drill 2 holes here for screws. This is actually the counterbore for the screw head. And it's got to go almost all the way through the piece of wood. And since I wanted to make sure it's perfectly vertical with the board, I don't want it to kind of poke off at the edge. I'm over here at the Bridgeport. So I've got this nicely set up, so I'll drill these holes here. Going to make lots of passes so that the chips don't get stuck in there. And then I'll take it over to the bench and can just finish off with a really long drill bit over at the bench. You can see I've got a nice little piece of tape on the end of the bit there to make sure I don't go too far through that board there. And then I'll drill another hole on the other side. It's just for the screw threads itself. The next thing I've got to do is attach that piece of wood that I was just working on to the load cell. So the load cell has some really big bolts in it. Those are 16 millimeter bolts. So I've got this thicker piece of maple that'll sit on top of that piece of cherry here. I'm punching 2 spots there for screws to attach that to the piece of cherry, and then another one that'll go in the center. And then in the center there I can make a big counter bore for that bolt to go through that'll then attach it over to the load cell itself. So take it back over the mill, drill the 2 holes for the screws on the side, and then I'm going to switch over and put a countersink in there. Now, I didn't realize at the time, but this countersink's actually on the wrong side of the part, so that's not super useful, but it's not going to hurt anything either. Once that's in there, I'm going to switch over and drill out the big counter bore for the bolt head there. That'll go most of the way through the part, and then I'll switch over to a smaller bit to drill it all the way through the part. I've got to move my parallels out of the way so that it doesn't hit them when it punches through. I wanted to make sure I did still have some parallels underneath there because these Forstner bits put a fairly large downward force on them. So now that's there, I need to tap the holes in the bottom of this anvil to attach the piece of cherry to. So I just take it over the mill. I always like tapping things in the mill so I can make sure that I keep everything straight. So I'm trying to use this tap wrench here, but the tap wrench is a little bit too big for that tap. So I got to switch over to this other wrench. I don't like this one nearly as much. It's kind of junky, so I need to get a new one of these days. But it does the job here, and I get that tapped pretty easily. So you can see I'm using some of that Tap Magic lube. I found that to be tremendously helpful. Before that I was breaking bits a lot, but that stuff seems to work really well. Once I've got that in there, I'll switch over to this little countersinking tool and just put a nice little deburr countersink on the top of these parts here. And that's the end of the actual shear tester part, but now I've got to make something to actually hold this and apply the force and hold it in place. So I could have just put this in a hydraulic press. I thought about doing that, but I don't really have one that would be set up nicely for doing this, so I'm just going to build one basically out of wood. So you can see before I had that hydraulic jack that'll be used to put the pressure on, and then this will be kind of the top support part of it. So I'm going to clamp it down to my workbench. My workbench has 4x4s on the bottom of it, so it'll be just as supportive of these. The way I'm going to clamp it is stick these clamps into these little dados here that I'm working on. I was having difficulty getting the chips to clear out of it real well, so I'm just using my little air blaster there. Obviously I don't have any coolant hooked up with it, but that'll just blast the chips out of this little mortise that I'm cutting in the bottom of this 4x4 post. So that goes almost the full depth of the bit there, and that'll allow the clamp to poke in and clamp down the frame of this tester here. Once I've got those mortises cut, I'll take it over the workbench and see how it works. You can see there's the tabletop and there's that aluminum rail underneath there, and then kind of behind and below that there's a 4x4 as well, so it's nice and strong. So I stick the clamp in there and it fits nicely, but I realized that my clamp isn't really deep enough to get to the center of the part, so I ended up switching that to some nice big bolts later on. That's the bottom of the frame taken care of. Now I've got to work on the top of it. So I'm going to end up cutting a little groove here and make a tenon on the vertical or the horizontal piece that goes over the top. These will be the vertical posts. So I'm going to lay that out now. Once I've got that all laid out, I'll take it over the bandsaw and cut the groove here and the tenon on the other part. And that's all I've got to do for the frame. So I'm screwing together here. I'm using 4 big screws. These screws will actually be under tension when this is being loaded. You can see the bottle jack is pushing up on the frame, and that's pushing up on the load cell, which is then pushing up on the top part here. So I want to use a lot of big screws here. I laid them out in the 4 corners. If this isn't strong enough, I can cut a big hole in the center and just put a big bolt to clamp everything together, and that should be plenty strong enough. I think these 4 screws should be enough, but just in case, I wanted to leave enough room for that if that's required.
I've got the shear tester all set up now. I installed the anvil with a little bit of grease to help it rotate around. That's to help it apply the load evenly. It also helps stick it up to the top part and not fall down when I take the samples out. Now this shear tester is meant to test one of these. It's a 2" by 2" square block that's glued together. These are kind of big. They're going to take a lot of force to break, and I'm a little concerned that I don't have this clamped down well enough. So instead I'm going to be using these 1" by 1" ones, which should give just as good results, but it's going to save me a lot of wood and it'll take a lot less force to break. So let's put this in there and see how it goes. That was a lot more exciting than I was expecting. It took 690 pounds to break that glue joint. That's a lot more than I was expecting as well. I thought it was going to be about 200 pounds, so I'm glad I didn't use these bigger blocks. I think I'm going to have to do something to keep it all arranged. You can see when it broke, it kind of jumped up and all kind of fell apart. So I may attach this to the top of the jack or put some braces on the side to prevent it from dropping all the way down or something. So other than that, though, I'm pretty happy with how it worked. It seemed to be able to break that without any problems. So thanks for watching. On the next video, I'm going to go ahead and make up a whole bunch of those glue blocks, different clamping pressures, and we'll test and see just how much clamping pressure is ideal for gluing up a joint. Thanks for watching.